Greetings, fellow students, and welcome to the hellishly edited and incompetently presented production of the Idaho Belt Supergroup. Please turn off your cell phones and pay attention, because according to the rubric, you will be grading us, and we'd rather not fail. A long time ago, in a galaxy that is totally this one, there existed a Proterozoic era, which occurred during the time period of 2500 MA to 545 MA. During this time, there existed a very large lake basin in what would one day be known as the Americas. This basin, amazingly, was filled with a lake. Deposition began to occur, as is often the case with lakes, and over time, layer upon layer of sediment began to build up. Time and pressure compacted and cemented the billions of clasts, big and small. Most of the clasts were made simply of silt or clay. This process created large swaths of sedimentary rock, mostly siltite or argillite. Further exposure to heat and pressure turned much sandstone, which had also been created, into the metamorphic rock quartzite, which is now interspersed with siltstone and limestone. Ah, rocks. Today there are many things that disturb their preservation. People, animals, even small burrowing organisms. But in the Proterozoic era, life was sparse. There were no animals, no bugs, not even plants that might affect the changes of the earth. Today, we can see mud cracks, ripple marks, and salt casts, which form during evaporation. From these preserved rock samples, we can catch glimpses of what life, or the lack of it, was like millions of years ago. Now, you may think that filled-in lake basins would be flat, and you'd be correct. You may also think that Idaho is anything but flat in the area of the Belt Supergroup, and again, you'd be correct. So how can these two things be true? The answer is plate tectonics. Reconstructing the configuration of ancient tectonic plates is far more difficult than simply viewing the area's rock history. This is due to the fact that the layout of the Earth's plates has changed dramatically in the last 1.5 billion years. Because we cannot accurately predict all tectonic plate movement, we cannot determine the area's complete tectonic history. What we do know is that the Belt Supergroup has experienced intense periods of both compressional and tensional stress. This has put a lot of strain on the rocks, causing them to deform both brittly and ductily. As such, faults and folds are some of the most common structural features found in the Belt Supergroup area of Idaho. This deformation has had incredible effects on the topography of the area. The Cabinet Mountains, which intrude into the panhandle and northeastern edge of Idaho, were formed in part by this deformation. Additional forces, such as huge glaciers, have cut large swaths of rock out of the mountains, forming the peaks, cirques, and arêtes that we see in Idaho today. The natural world may form huge vistas and interesting landscapes, all of which are worthwhile areas of study. But geologists may also put their skills to use for a very nice profit, assisting in both the discovery and retrieval of valuable natural resources found beneath the Earth. And in the Belt Supergroup, this means ore! No. Not war. Ore. One excellent example of this is the Silver Valley's Coeur d'Alene mining district, located in the panhandle of northern Idaho. The minerals come from veins and igneous rocks, which have intruded into the quartzite of the Belt Supergroup. Since its beginning in 1884, companies have pulled over 1 billion ounces of silver from the ground of the Coeur d'Alene, as well as large amounts of lead, zinc, copper, and antimony. All in all, this single mining district has produced over $2.89 billion worth of metal, little of which would be possible without the help of geologists.
I'm Jason Edgerton.
And I'm Cody R. Thank you for watching our presentation. We hope that you weren't bored enough to fall asleep, and we pray that you learned just enough to cover the criteria.